right. First and foremost, just cover quick here. In the See Spray nozzle selection overview, we're going to cover everything you need to know to make the right choice when selecting the nozzles for your See Spray sprayer. We'll also show you the different nozzle patterns that we're going to get and spray patterns we're going to get out of these nozzles. And then lastly, we're going to walk through a few different scenarios where we need to find a specific set of nozzles for a specific scenario we set up for this particular training. So jumping right into it, we've got a certain set of approved nozzles for See Spray. We've always had that since the beginning of the See Spray lineup, but for 2026, we have 5 different options that are going to cover all our bases for See Spray. It's always important to remember that we install any of these nozzles facing rearward on the B port of your See Spray machine. Another thing to remember is that incorrect nozzle tip sizing can be detrimental to having good performance with your See Spray system. As we can always remember, See Spray is a conventional spraying method. It's not pulsing, so we do not have the control over our target rate and droplet size irregardless of ground speed and pressure, right? So we're still spraying See Spray in a conventional mode, which is based on your ground speed and the pressure of the system. So with that in mind, a couple things that are new for 2026. They've got expanded portfolio of the targeted spray low drift nozzles, both in the 60 and 80 degree fan pattern angles. They've expanded the sizes that are available, but also they've changed the incline caps. So in the past, we've had those R4 incline caps that are multiple pieces. They've moved away from that design to the single molded design here. So next, let's go ahead and dive into what are some factors that may affect my overall savings. First and foremost is going to be our weed distribution. So where are the weeds in your field? Are they concentrated to certain areas like your headlands, or are they evenly distributed throughout the entire field? So this will dramatically affect the savings because your sprayer is going to be turning on and turning off more frequently with evenly distributed weeds. So if you've got weed pressure consistent across the entire field, you will see a lot less product savings than you do with weed concentrations that are focused on certain areas, maybe around waterways, maybe around your headlands, those higher pressure areas. You'll see better savings there. So that's one factor to consider when we are looking at our potential savings. Another thing too would be our fan angles. We have wide fan angles versus narrow fan angles. So wide fan angles are going to have more nozzles activate when it sees a particular weed. So the way the system works is essentially any weed that comes into view of the camera, and it can determine that any of the nozzles in that camera's purview can meaningfully touch that weed with a product, it's going to activate that nozzle. So wide fan patterns are going to have more effect putting more product out because more nozzles can actually hit those targets. So narrow fan angles, on the other hand, are going to be more targeted, and you will see higher product savings because it's going to actually activate less number of nozzles each time it sees a particular weed. So for example, if you're using a TSL 60 or a targeted spray low drift 60 degree nozzle, you're going to save significantly more than if you were to use, say, even an ultra low drift nozzle or a low drift max nozzle that has 120 degree fan patterns on those, even if they were sprayed in the same field. Another factor that we need to consider when it comes to our product savings, or at the end of the day, is our boom height. So boom height is going to affect the savings based on how many nozzles activate depending on how high the boom is, right? So the number of nozzles activated changes dynamically based on boom position and fan angle. The recommended boom height for See Spray applications is going to be roughly 20 inches above the crop or roughly 20 inches above the ground, depending on if you've got any sort of canopy or just spraying at the ground level. Last but not least, there's several settings inside the machine itself that actually affect how much product we save using the See Spray. Some of those settings are going to be the weed size filter. So essentially your sensitivity settings is what we've referred to it as in the past. So if you choose to run at the smallest setting to detect weeds in the field that are really, really small, so setting your weed size filter to the most aggressive setting, you will see less savings, and you're going to actually see even maybe some false positives in some cases. So we need to be wary of that, but also just make sure that we're hitting what we're trying to hit. Also, you may see more or less product savings depending on what size buffer zones you choose. So we've got small, medium, and large buffer zones in both length and width. You'll see less savings with wider and longer buffer zones, as you would kind of imagine. Moving into kind of the nuts and bolts, getting into the weeds here with the different nozzles we have available to us for See Spray. First and foremost, I want to touch on the targeted spray low drift nozzles. These are going to have some of the best savings overall of any of the nozzles we have to choose from for See Spray as far as product savings goes. So what scenario would you use either a 60 or an 80 degree nozzle? If your sprayer has 15 or 20 inch nozzle spacings, will determine whether you go with 60 or 80 degrees. So 60 degree fan angles were designed more for the 15 inch nozzle spacing setups. And then your 80 degree fan angles, so the TSL 80s, would be designed more so for the 20 inch nozzle spacings on your sprayers. These are not going to be as universal per se as if you were to use maybe a low drift max or a 3D nozzle, where you would use that in a broadcast application as well. You probably wouldn't use these in a lot of broadcast scenarios. However, these will see great savings and drift control and coverage with the See Spray application methods. Then we go into the extended range nozzles. Those are going to be 80 degree fan patterns. So I like to equate these to like essentially the 3D nozzle, but it's with an 80 degree fan pattern. So you'll see super similar characteristics between the extended range nozzle and the 3D nozzle that we've always had as far as droplet control and fan pattern. However, your fan pattern is reduced by 20 degrees with this extended range nozzle. So this one will improve the overall savings that you see by activating less nozzles each time it sees a weed. However, you do have to be wary of becoming drifty if you choose a nozzle that's on the smaller end of a range of different application rates and speeds. So these are probably not going to be super common just because we have the option to go with the 3D nozzle. So the 3D is going to be one of the most common nozzles that we have available to us today as far as covering a lot of broadcast scenarios and See Spray in the field. It's going to give us great coverage. So these nozzles are fantastic at creating the coverage that we need for those chemistries that require good coverage on the plant. When we're looking for that and we don't need to necessarily be concerned with a huge amount of drift, we can go with a 3D. And this is going to be right in the middle of the spectrum when it comes to the narrow versus wide fan angles. Last but not least is going to be our ultra low drift and low drift max nozzles. So these are going to be the widest fan angle we have available on any of the See Spray approved nozzles. They're going to have 120 degree fan angle, so you will see the most overlap and the lowest overall product savings. On the other side, these nozzles do have some of the best characteristics to reduce drift. So if you've got chemistries that you're worried about drift or you're close to susceptible crops or sensitive areas, these are great options for your See Spray machine. But not only that, they are super versatile in many other broadcast applications as well. Why are we hammering on choosing the right sizes necessarily for each scenario? There were a couple cases last year in 2025. Different applications had the wrong size nozzles. The case that we saw with an operator that had nozzles that were too big for the particular application, they were used to using the exact apply system, right? That's where a lot of you are coming from. See Spray, again, I said it earlier, but it is a conventional spray method. So in that scenario, they were applying too much product even while using the See Spray system. So they ended up coming short of product. That's why we're hammering on this nozzle selection and sizing so much. We want to help you guys avoid any issues with that going forward with your particular setups. That being said, I've got a couple scenarios here we can run through. First and foremost, what information do I need to select the right nozzles? So See Spray is a conventional spray method, just on and off, we're not pulsing. Therefore, we need to size them according to ground speed and pressure. So the pressure range guidelines are going to be between 30 and 50 PSI, and our ground speeds have to be below 15 miles per hour. Tip spacing, right? So do we have 15 or 20 inch nozzle spacing on our machine? What our average application speed is going to be, right? So we want to choose sort of an average. That way you can kind of push the top end of the limit a little bit, and then you do have the ability to slow down if you do want to, if you've got waterways or headlands you want to navigate a little bit easier without that higher ground speed. And then obviously the big one is your application rate. Do we want to apply, 10 or 20 gallons to the acre, whatever it may be? Our range for application rates with See Spray is going to be no less than 10 gallons per acre is what's recommended for See Spray, but also I think the highest end of the range is going to be 25, maybe 30 gallons per acre is probably the most common. And then our average pressure target, depending on what type of nozzle we select, whether we choose a low drift nozzle or a nozzle like a 3D or an extended range that's not necessarily a low drift but really good at coverage, that will help us determine what the pressure range we want to run that in at most of the time. And then just having a rough idea of what droplet size you need. So again, these are recommendations. Make sure you read your chemical label, whether or not it describes or prescribes a certain droplet size that's required for each of these chemistries, and even a specific nozzle technology. So if it does require a select set of nozzles for that specific chemistry, that's still going to take precedence over the guidelines for See Spray nozzle selection. So always follow your chemical label instructions on what nozzles you need to select. So our first scenario here, we've got our first post pass in the field with See Spray. For this scenario, we've got a tip spacing of 15 inches. Our average application speed is going to be roughly 14 miles per hour. So not going to be at the very top, but also going to be able to give us a little flexibility to push the top end of the range and also bring it down just a little bit. And our application rate is going to be shooting for 20 gallons per acre with an average pressure target of 45 PSI. And then our droplet size, we're gonna shoot for coarse to extra coarse. So that may mean that we're gonna be looking at a low drift nozzle. So we'll determine that here in the next slide. So if we take a look at our nozzle selection chart, we've got our 15-inch nozzle spacing chart here. We're gonna be doing 20 gallons per acre. So we're gonna be living at the top end of this range here. And our 45 PSI, if we wanna be in there, we're gonna be roughly right here. So an 06, we may be able to get by with a 0.6 gallon per minute nozzle. Let's take a look at the 08 size nozzle, or the 0.8 gallon per minute nozzle. So 45 PSI, that's gonna give us a little bit higher speed range if we were to go with that. So depending on what nozzle technology we go with, will help us determine whether we wanna go with an 06 or an 08. So that's gonna be our pressure ranges and speeds. With that information that we know, we'll come up with a few different options. There's 4 main options that actually come up in this scenario. The first and most common option is going to be a low drift max nozzle. So this is going to give us really great drift control, even at higher pressures. Our next option is going to be ultra low drift. That's going to be an 06 size. It probably wouldn't go any bigger than that. This is going to be super similar characteristics to the low drift max nozzle that we just discussed. However, you won't be able to pulse if you were to go in a broadcast scenario with this ultra low drift nozzle. So that's probably a bigger reason why people would go with a low drift max nozzle, is just give them that flexibility to go back and forth between a broadcast while pulsing and a See Spray application. Another couple of different options we've got are going to be our targeted spray low drift 60-degree nozzle. Because we have that 15-inch nozzle spacing, if we were to look to optimize for the most savings possible, we would go with this targeted spray low drift 60 nozzle. They're going to have similar characteristics in droplet size and drift control to our ultra low drift and our low drift max nozzles, while giving us that consistent product savings by having the narrower fan angles and having less nozzles activate each time that it sees a particular weed. Just a little snippet here from my experience when choosing a low drift nozzle. When we get that range of nozzles to choose from as far as sizes go, so we had that 06 or that 08, I typically go with one that's on the lower end of the size range. We want to spray at a little higher pressures to achieve an even and uniform density of droplets. So if we end up spraying at lower pressures with a low drift nozzle, you don't get super great coverage, and then you lose a little bit of efficacy in some scenarios, especially if you're spraying an herbicide that requires good coverage. Moving on to scenario number 2. We've got a 20-inch nozzle spacing or tip spacing there. We've got our average application speed of roughly 14 miles per hour again, and our application rate this time is going to be 16 gallons per acre. Average pressure target is going to be roughly 40 psi, and then our droplet size we're looking for in this scenario is going to be medium to very coarse. This may mean that we don't necessarily need a low drift nozzle for this, so we'll take a look at our chart here, our nozzle pressure and speed chart. In this scenario, 16 gallons per acre application rate, and we want to go 14 miles per hour on average. So we're going to be living in this range right about here with that 13.6 to 14.7 ground speed. That's going to be a little higher on our pressure range. So maybe we're going to be looking at an 08 size nozzle. So let's feign 16 gallons per acre. There's our 14.9 and ground speed right there, miles per hour. That's 40 psi. So that's probably what we're going to go with for sizing here. So 3 main options come to mind or stand out here. First and most common option is going to be that 3D 08. The 3D is going to give us that great coverage, creating those medium to coarse droplets, even at pressures in the higher and lower ranges. The other 2 options that we come up with in this scenario are going to be our TSL 80s and TSL 60s. If you remember back to our parameters, we have a 20-inch nozzle spacing. So that's going to mean that if we do go with the TSL or targeted spray low drift nozzle, we would go with the TSL 80. That is going to be the types of nozzles that we can choose from, or we should choose from in this scenario. From my experience, if we wanted to choose a low drift nozzle, we'd probably want to choose one that would require at least 50 psi for a majority of the time that we use that in the field. This is going to help us reduce maybe some of the large droplets, so we get more uniform density and coverage. On the other hand, I find that choosing a 3D nozzle, if you do go with a 3D nozzle, I like to choose the 3D nozzle that's on the higher end of the size range. For example, we've got an 06 or an 08 nozzle. I would definitely go with the 08 if we're going to not be applying products even more in higher gallon ranges or lower speeds. So this 3D 08 would be a great fit with that 16 gallon per acre rate that we're wanting. All right, so to kind of wrap the section up here, some of the key takeaways, I really want you guys to take a good look at what you have for nozzles right now, and just to see if that's going to fit your needs for this season coming up as well as just a resource to have available to you, as maybe download Equipment Mobile, have it on your phone, just to give you that nozzle calculator in your pocket so you can enter in those parameters and on the fly and just see where your size spectrum is going to land. If you do have any questions on any sort of software or anything like that, we want you to get a hold of your service department locally and just ask them what they can do to make sure you're on the latest software. 25-2 or 3 is going to be the software version or software range that we're going to be using spring this year. And as always, feel free to contact the support center. That being said, thank you guys.